students. In this session, I am going to explain you about molecular orbital theory. In this molecular orbital theory, I am going to focus on discovery of molecular orbital theory, why this molecular orbital theory has been discovered, and what are the postulates are present in this molecular orbital theory. Coming to discovery of the molecular orbital theory. In the year 1929, Robert S. Mulliken and Friedrich Hund has been developed this molecular orbital theory. Why this molecular orbital theory has been developed? Because with this molecular orbital theory, we can able to know the interaction of atomic orbitals while they are forming a bond, chemical bond. Coming to postulates. To explain these postulates, I will take an example. With that example, point by point, I will explain these postulates. Coming to that example, let's take hydrogen molecule. If hydrogen molecule wants to form, definitely there should be two hydrogen atoms participate in the bonding. So means that hydrogen atom plus hydrogen atom combine each other and gives H2 molecule. How these hydrogen and the hydrogen combine each other? Through atomic orbitals of this hydrogen atom, another atomic orbital of hydrogen atom linearly combine each other and they will produce H2 molecule. Let's check it. In hydrogen atom, hydrogen electronic configuration is 1s1. Other hydrogen atom electronic configuration also is 1s1. When 1s1 and other 1s1 linearly combine each other and they will produce the same number of molecular orbitals. Means that here two atomic orbitals are participating in the bonding, so two molecular orbitals will be generated according to molecular orbital theory. So these two molecular orbitals will get different energy levels when compared to atomic orbitals. If the molecular orbital will get lower energy than atomic orbital energy level, that can be called as bonding molecular orbital. If the molecular orbital will get higher energy than atomic orbital energy level, then that molecular orbital can be called as anti-bonding molecular orbital. Now let's give the name what exactly bond it is. To know that, let me tell you the interaction of pi bond and sigma bond. What are the pi bond and sigma bond? These two bonds are the covalent bonds. Especially this MOT will explain the covalent bond molecular orbitals. So if any orbitals head-to-head overlap is there, then that will give sigma bond. For example, s orbital is spherical. Another s orbital also will be spherical. These both can be overlap head-to-head. Then this bond can be called as sigma bond. Always s orbital leads to give sigma bond only. When p orbital is there, dumbbell, s orbital is there, both can mix each other. That time also they will give sigma bond only, because s orbital will overlap with p orbital head to head time. So if p orbital is there, another p orbital also will be there. If they can combine head to head fashion, and that will also lead to give sigma bond. If p orbital is there, other p orbital is there, if they overlap laterally, lateral overlap will be there. If lateral overlap is there, then that bond can be called as pi bond. Pi bond. Understand? These are the sigma bonds and pi bond formation information. So now coming to here, when 1s orbital, s orbital combine each other, they will give sigma bond. Sigma bonding molecular orbital. What kind of orbitals here participating? 1s orbital. So sigma 1s bonding molecular orbital. This is. Here sigma star anti-bonding indicates that star mark. So sigma star 1s. This is anti-bonding molecular orbital. So coming to postulates, what are the bonding molecular orbitals? What are the anti-bonding molecular orbitals? Now you are understand clearly what is bonding molecular orbital, what is anti-bonding molecular orbital. And then coming to energy level of molecular orbitals. See, if you check the energy level of molecular orbitals, here lower energy is sigma 1s, higher energy is sigma star 1s. This is the energy levels. So coming to electronic configuration of H2 molecule. Like in atom, electronic configuration is 1s1. Coming to molecule, H2 molecule electronic configuration, sigma 1s less than sigma star 1s. And we have to fill the electrons. So here one electron, other electron is here. So two electrons are there. Any orbital is capable to hold maximum 2 electrons only. So that 2 electrons will be here, and here no more electrons are present. So sigma 1s2 less than sigma star 1s0 is the electronic configuration of H2 molecule. Understand? And what extra points MOT will explain? That can explain you bond order also. How bond order can be calculated by using MOT theory. MOT theory. See, bond order is equals to bonding electrons minus anti-bonding electrons divided by 2. This formula will give you the bond order in between two atoms. What are the bonding electrons? What are the electrons are present in the bonding molecular orbital? Those electrons can be called as bonding electrons. What are the electrons are present in anti-bonding molecular orbital? Those electrons can be called as anti-bonding electrons. In this example, bonding electrons are sigma 1s2. 2 electrons are there. Those 2 electrons are bonding electrons. No more electrons are there in the anti-bonding orbital. So 0 will be there, and by 2 indicates that 1. 1 means in between hydrogen atom, there will be a single bond. Right? Next point. What this MOT extra will explain? Magnetic nature of the molecule. What is the magnetic nature of the molecule? How it can explain? If in these orbitals any paired electrons only present there, then that molecule can be called as diamagnetic molecule. If unpaired electrons are there in any molecular orbitals, then that molecule can be called as paramagnetic molecule. In this case, only paired electrons are there in sigma 1s. There are no electrons in anti-bonding molecular orbital. So 2 electrons are there, the 2 electrons are paired up. So this molecule can be called as diamagnetic molecule. And stability. This stability is a little difficult. Means that if we want to tell the stability of any molecule, we have to take a ratio of bonding electron and anti-bonding electrons. Here bonding electrons are highly present compared to anti-bonding molecular orbitals. So this molecule is very, very stable. So by using MOT means the postulates, by using this example, we are checking point by point. What are the bonding molecular orbitals? What are the anti-bonding molecular orbitals? What is the energy level of bonding and anti-bonding molecular orbitals? And what is the electronic configuration of the molecule? What is the bond order present in the molecule? What is the magnetic nature of the molecule? What is the stability of molecule? These all kind of postulates from MOT we are explained by using this H2 molecule. Clear? Next, let's check one more example, that is O2 and CO molecules.